Hello. Today, we give a solution to the circuit problem part 2. First question is, what is the potential AB? What is potential at A and potential at B? There are two conditions. One condition is the switch S is open. Another condition is the switch S is closed. First, we answer the question. What is the voltage between A, B when switch S is open? When S is open, this resistor, 3 ohm resistor, has no effect. It looks like there is nothing there, nothing between A, B. So that is the situation when S is open. Therefore, this question, the potential AB, is the same as the same circuit problem part 1. In part 1, we don't have the 3 ohm resistor. So the answer is the same as the part 1 answer. So in part 1, we already answered the question, VAB, which is 12 volts. And VB is higher than VA. So VBA is 12 volts. Or you say the opposite way, VAB is negative 12 volts. So this is how you answer the question. Same as part 1. So VA is 12 volt. VB is 24 volt. So VAB is 12 minus 24 is negative 12 volts. Or you may say VBA is 24 minus 12 equals 12 volts. B point is at higher potential. The next question, we close the S. The switch S is closed. What is the current through the switch S? Is the current from A to B or from B to A? S is closed. There is a current passing through S. Is the current from B to A or from A to B? And what is the magnitude of the current? So this current, this part B problem, we need to do something regarding the two nodes, A and B. When you close the S switch, so you just write the 3 ohm resistor is between A and B. At point B, this current plus this current should equal to this current. I1 plus I5 should equal to I2. So I5, oh no, I made a serious mistake. This current is going down and it is divided into two paths. So I1 is divided into I2 and I5. Therefore, I1 is equal to I5 plus I2. And at point A, you have current going down here and another current going down here. So this current is approaching point B. This current is leaving point B. And there is another current approaching point A. Therefore, the three currents are related by I4. I4 is the current leaving point A. Current leaving point A should equal to the sum of current approaching point A. So it's I3 plus I5. I3 plus I5 is equal to I4. I1, this current, is the voltage difference across the 3 ohm resistor. So I1 is 36 volt minus minus VB divided by 3. What is I2? I2 should be this voltage divided by 6 ohm. Okay, this point is 0 voltage. This is 0 voltage. So the voltage across 6 ohm resistor is just VB. So I2 is VB divided by 6. What is I3? I3 is the voltage difference across the 6 ohm, which is 36 minus VA. So 36 minus VA divided by the resistor 6 is I3. I4 is VA. This is 0, so it's just VA divided by 3. What is I5? It's VB minus VA divided by 3. We draw the I5 from VB to VA. So we assume VB is larger than VA. If it comes out VB is less than VA, then it's just the opposite direction. So it doesn't matter. Yeah. So I5 is this. So I have I1, I2, I3, I4, and I5. Substitute 1, 2, 3, 4, 5 into here. 1, 2, 3, 4, 5, and 5 into these two equations. I get these two equations. I repeat, these two equations. After I substitute I 1, 2, 3, 4, 5 into these two equations, I get another two equations, which is here. Now I want to get rid of the denominator. 3, 6, 3, the common denominator is 6. So I multiply 6, multiply 6, multiply 6, I get this. The second equation, the common denominator is also 6. I multiply everything by 6. I get this, this, this. So these two equations become these two equations. Simplify VAVB. Put VAVB on the left-hand side and put the constants on the right-hand side. So these two equations become these two equations. Now, these two equations are in the standard form of two equations, two unknowns. Two unknowns are VA, VB. So we can solve for the two unknowns using either substitution or elimination. I'm not going to show step by step the detail of solving these two unknowns. The result is VA, this, so simplify, continue, it's 108 divided by 7 volts. And VB is this. Once I have VAVB, I can answer the question, what is the current through the switch S. So the current through the switch S is the current across the 3 ohm resistor divided by the 3 ohm resistor. So it's VAB minus VA. Then the result is 12 over 7A. You see here VB is larger than VA. So the current goes from point B to point A. So this is the answer for the next part. Yeah. Actually, it's not the next part. This is the answer for this part we are talking about, for this part. Okay. The next question is, what is the equivalent resistance looking from the terminals of the battery? Now you look at the circuit. What is the current supplied by the 36-volt battery? What is the current supplied? The current supplied by the 36-volt battery is the sum of I3 and I1. These two currents are going out from 36-volt battery. So what are the sum of I1, I3? I1 plus I3. You go back to the calculation here. So again, I'm not going to give you the details. So once you have VAVB solved, VAVB, you have all the 5 currents, I1, I2, I3, I4, I5. You have all the 5 currents after you found VA and VB. Therefore, we know all 5 currents. Then we can answer the question. I3 plus I1 is, you go to the calculation, you get this. Then the equivalent resistance, looking from the point of view of the 36-volt battery, is the voltage divided by the total current. 36 divided by the total current. So you get 21 over 5, which is approximately 4.2 ohm. Okay. So this is the equivalent resistance after you close the switch S. The next question we want to answer is that before you close the switch S, when the switch S is open, what is the equivalent resistance? Again, you want to find the total current. What is the total current? When the switch S is open, so go to the same circuit. If the switch is open, this resistor is not here. So you only have 4 resistors here. And you see, this branch is 9 ohm total. This branch is also 9 ohm total. Okay. So the 9 ohm and the 9 ohm are in parallel. So what is the equivalent resistance? It's half of 9 ohm, is it? So it's 4.5. So this is a concept. You see, 9 ohm in parallel with 9 ohm, so it is half. But you can also find the total current and find the equivalent resistance. What is the total current if the S is open? 36 volt divided by 9 is 4 ampere. So 4 ampere through each branch. 4 ampere through here. 4 ampere through here. So that 8 amperes altogether. If the battery supplies 8 amperes altogether, total current is 8 ampere. The battery supplies 8 amperes altogether. So the equivalent resistance is 36 divided by 8 is 4.5 ohm. So you will see that the effect of closing the switch is to reduce the effective resistance a little bit. If the S is open, it's 4.5 ohm. If S is closed, it's 4.2 ohm, a little bit smaller. And this is what we can guess from the circuit diagram. If you close the switch, the 3 ohm is present. When you have 3 ohm present, it's easier for the current to pass through because you have one more branch. So it's easier for the current to pass through, then the resistance should be less. This answers our problem, our part 2 of the problem. Part 2 of the problem. Okay. This circuit problem, part 2. Again, I want to mention that there are 2 viewers who provided answers. So please go to the reference. The reference are comments in the comment section from these 2 persons. I should thank these 2 persons for interaction with the readers of my channel. Thank you for watching. Goodbye.